Hello students, my name is Professor Muhammad Asim and we are doing additional mathematics. Additional mathematics for those students who are doing Igcse, which have syllabus code 0606, and for those students who are doing CIE O level which have syllabus code 4037. So both kinds of students can get equal benefit from this course. As you know, students, we have started chapter number 2 from this book. Name is Simultaneous Equations and Quadratics. And we have finished exercise 2.1 and we started exercise 2.2 and did first 7 questions. Today we are going to do some more questions from this exercise 2.2. Let's have a look question number 8 on your screen. Part A. Question number 8. Express 4x square plus 2x plus 5 in the form a into x plus b whole square plus c, where a, b and c are constants. Very easy. You have already done these type of questions from question number 4, 5, 6 and 7. So let's start part A. 4x square plus 2x plus 5. So what I told you in previous questions, first we have to see is there any coefficient of x square or not. In this part the coefficient of x square is 4. So we have to take common from first two terms. We have to take common the coefficient of x square, that is 4. We are taking common 4. So 4 ones are 4, this is x square, and this is 2, this is 4. So it should be 2 upon 4x. And this plus 5 remains plus 5. Now, second step is simplify this 2 and 4, 2 to the 4. So it will be 1 upon 2x plus 5. Now focus on the coefficient of x. The coefficient of x is 1 upon 2. So always divide the coefficient of x by 2. So it will be 1 upon 2. Convert this division sign into multiply sign. It will be 1 upon 2. 1 ones are 1 and 2 twos are 4. Now see these two results. This one on top of the screen and this one. So we have to apply the result number 1. So it will be 4, open the bracket, x plus 1 upon 4 whole square minus 1 upon 4 square, bracket close, and this plus 5 remains plus 5. Now 4 into x plus 1 upon 4 whole square minus 1 upon 4 square. 1 square is 1 and 4 square is 16. Bracket close, and this plus 5 remains plus 5. Now multiply this 4 by the whole bracket. So it will be 4 into x plus 1 upon 4 whole square minus multiply this 4 by 1 upon 16. So it will be 4 multiplied by 1 upon 16. And this plus 5 remains plus 5. So 4 into x plus 1 upon 4 whole square minus 4 ones are 4, 4 fours are 16. So it will be minus 1 upon 4 plus 5. Now 4x plus 1 upon 4 whole square. Simplify this minus 1 upon 4 plus 5. The denominator of this 5 is nothing. It means it's 1. Now taking LCM 4 and then solve. So I am solving this directly. 4 5s are 20. 20 minus 1 is plus 19 upon 4. And you can also you can also get this answer by taking proper LCM. Okay. So 4x plus 1 upon 4 whole square plus find the answer of 19 upon 4 with the help of calculator. You will get 4.75. 4.75. This is the answer of part A. The requirement is express 4x square plus 2x plus 5 in the form of a into x plus b whole square plus c. And we have achieved the form, required form. Okay, come to part B. See carefully, read carefully part B. Does the function y is equals to 4x square plus 2x plus 5 excuse me, does the function y is equals to 4x square plus 2x plus 5 meet the x-axis? Explain your answer. It means if you draw the graph of this function, so can this curve, and you know the graph of quadratic function is always a parabola. So can if we draw the function the graph of the given function, so after drawing, can the graph meet the x-axis or cuts the x-axis? What does it mean? I am drawing a random graph like this. For example, this is the quadratic graph. So this graph is meeting x-axis at this point and this point. But the question is this function y is equals to 4x square plus 2x plus 5 meet the x-axis? How can we say that the answer is yes or no? First is to draw. There are two options. First is to draw the whole graph of the given function and check whether the graph is crossing the x-axis or not. But this is very long procedure. There is another option to give the answer directly. How? Just write the answer of part A again. Y is equals to 4x plus 1 upon 4 square plus 4.75. What is the question? Can this graph cuts the x-axis? You know, students, and you must know at x-axis, the value of y is always 0. So if we put 0 in this function, y is equals to 0 in this function, we will get 0 is equals to 4x plus 1 upon 4 whole square plus 4.75. If we transfer this 4.75 on other side, it will be 4 minus 4.75. So 4x plus 1 upon 4 square. This 4 is multiply over here. This should divide on this side. So minus 4.75 upon 4 is equals to x plus 1 upon 4 whole square. Taking square root on both sides in order to eliminate eliminate square. So minus 4.75 upon 4 square root with plus minus sign is equals to x plus 1 upon 4. But students, we are unable to find the negative value, square root of negative value. If we find the square root of minus 4.75 upon 4, our calculator will show the math error, or some calculator, some more programmable calculator says the division, the square root of negative number is not allowed. This shows that our question is, does the function y is equals to 4x square plus 2x plus 5 meet the x-axis? Answer is no. Answer is no. No, since since 4.75 is greater than 0. Greater than 0 means positive. This is our answer. So it means what we have learned from this part, if this value, if this value, this one is positive, then the graph will not will not crosses the x-axis. So final answer is no. Why? Because 4.75 is positive, greater than 0. So what is the question? Does the function y is equals to 4x square plus 2x plus 5 meet the x-axis? No. Explain your answer. I have given the complete explanation. So very important question and very knowledgeable questions. I hope you completely understand. Now move to question number 9. This is question number 9. Fx is equals to 2x square minus 8x plus 1. Express 2x square minus 8x plus 1 in the form of a into x plus b whole square plus c, where a and b are integers. So this is part A, not new for you. We have done these kind of parts so many times. Fx is equals to 2x square minus 8x plus 1. So first we have to take common from these two terms. So I am taking common 2. It will be x square minus 4x. And this plus 1 remains plus 1. Now focus on the coefficient of x. The coefficient of x is 4. So 4 divided by 2 is 2. After this, apply result number 2 as you can see on the screen. So 2 multiplied by x minus 2 whole square minus 2 square bracket close, and this plus 1 remains plus 1. So 2 into x minus 2 whole square minus 2 square is 4 plus 1. Now multiply this 2 by the whole bracket. So 2 into x minus 2 whole square minus 2 fours are 8, and this plus 1 remains plus 1. So 2 multiplied by x minus 2 square minus 8 plus 1 is minus 7. This is the answer of part A. Now, this is the answer of part A. Part B. Find the coordinates of the stationary points. Find the coordinates of stationary points. You know, students, another name I already told you in previous lectures. There is another name of stationary points called turning points. So you must keep in your mind that stationary points and turning points are same. How to find stationary point or turning points? It's very easy. In order to find stationary points or turning points, the standard equation is y is equals to a multiply by x minus h square plus k. In order to find stationary point or turning points, your equation must be in the form of y is equals to a into x minus h square plus k. And if you are successful to write the equation in this form, then you can say here h comma k is stationary points. Stationary points or turning points. Now come to your answer of part A. Our answer is y is equals to 2 multiply by x minus 2 whole square minus 7. So if you compare our answer with the general equation x minus h square plus k, and if you know that hk is stationary points, then you can find hk. If you compare, hk is equals to 2 comma minus 7. How? You can compare here. A is 2, but A is not required in this case. X minus minus H2. So H is 2 and K is minus 7. So this is the answer of part B. So you must keep in your mind, in order to write stationary point or turning point, your equation must be in the form of y is equals to a into x minus h whole square plus k. Hope you understand. Now start question number 10. This is question number 10. Fx is equals to x square minus x minus 5. For x belongs to R or x in R, R stands for real numbers. R stands for real numbers. Real numbers means any number is the real number except square root of negative number. All numbers are real numbers. What is the question? Find the smallest value of fx and the corresponding value of x. Very easy. First, we have to write the given equation. Fx is equals to x square minus x minus 5. We have to write the smallest value of x, smallest value of fx and the corresponding value of x. Students, in order to write a smallest value of a function, the function must be in the form of perfect square. Like you can see in the top, on the top of the screen, the result. So first we have to write the given function in the form of perfect square, and you know all the steps. What is the coefficient of x? Is 1. So we must divide the coefficient of x by 2, and now fx is equals to, apply result number 2 in, you can see on above, top of the screen, x minus 1 upon 2 whole square minus 1 upon 2 whole square, and this minus 5 remains minus 5. So x minus 1 upon 2 whole square minus 1 upon 2 whole square is 1 upon 4 minus 5. Simplify minus 1 upon 4 minus 5 directly from the calculator, or you can take the LCM. So x minus 1 upon 2 fx is equals to x minus 1 upon 2 whole square, 4 5s are 20, 20 and 1 minus 21 upon 4, and fx is equals to x minus 1 upon 2, or we can write 1 upon 2 is 0.5 whole square, and minus 21 upon 4. If you find 21 upon 4 from calculator, you will get 5.25. 5.25. Now, we are successful to write the function in standard form, or you can say perfect square form. I am reading part A again. Find the smallest value of x and the corresponding value of x. Student, how to find the smallest value of the function? It's very easy. To find the smallest value of fx or y, because you know y and fx are equal, you must focus on this whole square term. The whole square term is x minus 0.5 whole square. So in order to find the smallest value of the function, we should put the value of x in this whole square bracket so that the overall answer is 0. So what value we have to put in the function? Obviously, if we put 0.5 in the function, we will get 0.5 minus 0.5 whole square minus 5.25. 0.5, 0.5 cancel, and 0 square is 0 minus 5.25. So, and 0 minus 5.25 is minus 5.25. So, for x is equals to 0.5, then y is equals to minus 5.25. And obviously, this value minus 5.25 is the smallest value. Why? If I put the value which is greater than 0.5 or less than 0.5, we will get the answer greater than minus 5.25. So the smallest value occur only when x is equals to 0.5. Hence, our answer is, what is the requirement of the question? I am writing final answer over here. Final answer over here. What is the requirement of the question? Find the smallest value of fx. The smallest value of fx is minus 5.25. Minus 5.25, and the corresponding value of x. Corresponding value of x is 0.5. This is final answer of part A answer. Hope you understand. Very important part according to examination point of view. Okay. Now focus on part B. Hence write down a suitable domain for fx in order that f inverse x is exist. Student, whenever you see the word, whenever you see the word hence in math, whenever you see the word hence, it means we should help, we should have to take the help from the previous part. Hence write down a suitable domain for fx in order that f inverse x exists. It means we have to write the answer in the form of, it means we have to take the help from the previous part. Okay, so hence means take the help. I am rubbing this. What is the question? Write down a suitable domain for fx in order that f inverse x exists. Student, domain means domain of fx. Domain of fx means value of x. X means domain and fx means range. So in this case, we have to write the value of x so that the inverse of the function exists. What does it mean? Student, when we did chapter number 1, function, exercise 1.1, we saw that inverse of the function is exist if there is one input value and one output value. I want to show exercise 1.1 again. Okay, here we go. See this diagram. The first graph is 1 1, and if you see these two lines below the graph, you can read for one input value there is just one output value. Input value means x, output value means y. So if the function is 1 1, then its inverse is exist. Otherwise, if the function is not 1 1 or many 1 or 1 many, then the inverse is not exist. So for in order to exist inverse of a function, our function must be 1 1. Okay, so with the help of this, I am going our question of exercise 2.2 again. See this, hence write down part B, hence write down a suitable domain for fx in order that f inverse x exists. So I am writing the answer over here. The answer of part B is very small. That is, x should be greater than equals to 0.5. So if x is equals to 0.5 or greater than 0.5, then the inverse is exist. It means for this value 0.5 and greater than 0.5, the function remains 1 1. And if the function is 1 1, then the inverse can exist. So this is the answer of part B. But I want to give you more explanation. Excuse me. See this. Fx is equals to x. Fx is equals to x minus 1 upon 2 means x minus 0.5 whole square minus what is the answer of 21 upon 4 is minus 5.25. Okay, I want to show this. What I wrote, the value of x should be greater than equals to 0.5. If I put the value of x, let x is equals to, for example, minus 1. So minus 1 is less than 0. So what should be the answer? Minus 1 minus 1 minus 0.5 whole square minus 5.25. If I find the answer with the help of calculator, our answer is minus 3. Okay. If I put if I put the value of x instead of minus 1, if I put the value of x, for example, 2, so 2 minus 0.5 whole square minus 5.25, so it will be 1.5 square minus 5.25 is equals to, I will get minus 3 again. So at x is equals to minus 1, I will get minus 3, and at x is equals to 2, I will get minus 3 again. So if I take the values which is below 0.5, the function will no more 1 1, and if the function is not 1 1, then its inverse is not exist. Therefore we should take the values which is equals to or greater than 0.5. Hope you understand this point. Okay, students. So the answer of part B is x greater than equals to 0.5. Okay, students, this is our today's class where we did three questions. Question number 8, question number 9, question number 10. But some more questions left in this exercise from question number 11 to question number 16. We will try to finish this exercise as soon as possible. And you know, I always do all questions, all parts, and try to give too much explanation. Or you can say, I try my best in order to explain you. But if still if you have any problem, write in comment box, I will help you. Kindly do subscribe my channel if you like my videos, and press the bell icon button so that wherever I upload my lectures, you will get the notification. Kindly share my videos to all of your friends as well. Okay, students, good luck for next lecture.